Hello everyone, I'm Sahiti from Edureka and welcome to today's session on microservices tutorial. So thank you all the attendees for joining in today's session. So first let's start by looking at all the topics we're going to cover in today's session. We will start by understanding what was before microservices, that is the monolithic architecture, and then see its challenges. After that, we will deep dive into what are exactly microservices and then learn more about its architecture. Finally, I will end this session by showcasing a practical implementation of microservices on Eclipse using Spring Boot. So guys, I hope that you're clear with today's agenda. Now many of you may think, why should you learn microservices? Well, I could justify by saying that many multinational companies such as eBay, Netflix, Amazon, Uber use microservices in their company structure. Not just the multinational companies, but the percentage of people using microservices has also tentatively increased. Looking at the job opportunities, the average salary of microservices ranges from approximately $97,000 per year for a software engineer and a range of $116 per year for a senior software engineer. Isn't it great? So now that you have a good reason to learn microservices, let's deep dive into learning more about microservices. Look at the scenario on the screen. Here, Alice watches TV shows using an online media service called MediaMore.com, which is similar to your Netflix or Amazon Prime. So basically, MediaMore is an entertainment company which provides streaming media and videos online. It consists of various genres of TV shows with different languages, just like Netflix and Amazon Prime. So in the past, MediaMore was also built as a large monolithic application where a team of developers would take a lot of time to build all the features in the application on a single code base. So here, developers had to rewrite the code for every part of the application. It's really confusing, isn't it? Let me give you a proper definition of monolithic architecture. Monolithic architecture can be defined as a framework wherein all the features of the system are put on a single code base and are under a single database. So your features such as recommendations, most popular, content catalog are all put on a single code base and are on a single database. Now, after decades of software development, there are vast amount of codes already present out there that the developers can use as a base of their application. So why would the developers want to rewrite the code again and again? But here, since MediaMore uses the monolithic framework, this raises a fantastic question about the challenges about this architecture. So now, let's look into the challenges of the monolithic architecture by looking at some scenarios. Scenario 1. Assume that the developers wanted to make immediate changes in the application. How would they do this? Well, the monolithic application can definitely accommodate these changes, but the problem here is that the developers must rebuild the code for every small change they make in any particular feature. So even if they want to update a small change in a particular feature, the complete system must be reframed again. Look at the second scenario, where the developers want to update all the playlists according to the most popular TV shows and also want to simultaneously update all the videos to the HD quality. In such scenarios, developers cannot scale the application simultaneously. Instead, new instances of the same application must be created every time a new feature has to be developed or deployed. Coming to the third scenario, consider the scenario where developers of this application are comfortable with various technologies like Java, C++, .NET, C#, etc. Now, in such situation, even though they're comfortable with various technologies, they still have to build large and complex application on a single technology, that is on the technology MediaMore was built. Finally, consider a situation where a specific feature is not working in the application. In such scenarios, the complete system goes down because of this problem. In order to tackle this problem, the application must be rebuilt, retested, and redeployed. This means that the application has to be built from the scratch again. So now, all of you might be thinking, how will the developers of MediaMore overcome these complexities? Well, developers decided to re-architect their monolithic application into multiple individual deployable components called as microservices. So here is the million-dollar question. What are microservices? Microservices is an architecture wherein all the components of the system are put into individual components which can be built, deployed, and scaled individually. This means that each component is independent of each other. Okay, so Rohit just asked me a question if I could simplify the definition of microservices. So Rohit, let me explain you with a simple analogy. You must have seen how bees build their honeycomb by aligning hexagonal wax cells. They initially start with a small section using various materials and continue to build a large beehive out of it. These cells form a pattern resulting in a strong structure which holds together a section of beehive. Here, each cell is independent of each other, but it is also correlated with the other cells. This means that damage to one cell does not damage to the other cells. So, bees can reconstruct the cells without impacting the complete beehive. Look at the diagram on the screen. Each hexagonal shape represents an individual service component. So, similar to the working of the bees, each agile team builds an individual service component with the available frameworks and the chosen technology stack. So the recommendation system can be built on a specific technology. The video uploading team can build this feature on a specific technology, and so on. Just as in a beehive, each service component forms a strong microservice architecture to provide better scalability. That is, a particular service can scale at its maximum without impacting the other services. Also, issues with each service component can be handled individually by the agile team with no or minimal impact on the entire application. So, even if any one feature is down, this does not close down the complete application, but only that particular feature has to be rebuilt. So Rohit, I hope I've simplified the definition for you. Coming back to the scenario, consider a situation when you log into your account on Netflix or Amazon Prime. What do you all see? You just see the recommended shows, right? So similar to that, when Alice logs on into her account, she sees a list of recommended shows. But after some searching, she finally gets a TV show she wants to watch. Now, what if Alice wants a TV show with just a single click? How will the developers of MediaMore fulfill Alice's request? To fulfill Alice's request, developers of MediaMore decided to shift their application from a monolithic architecture to microservices. But before getting into how did the developers shift their monolithic framework into microservices, let me brief you a little bit about different parts of microservice architecture. The architecture consists of various users who send requests from various devices. These requests are authenticated by the identity provider and are passed on to the API gateway. API gateway thus acts as an entry point for all the client requests and passes the request to the specific microservices to be processed. Apart from the main components, the architecture has other parts also such as static content, which houses all the content from the system, service discovery, which acts as a guide to find the route of communication between microservices, the content delivery networks, which is basically a distributed network of proxy servers and their data centers. Now, all of you might be thinking, how will these parts work together on MediaMore application to process Alice's requests? Alice's request is first passed on to the identity provider. Then, the identity provider thus authenticates Alice's request by identifying her as a regular user on MediaMore. These requests are passed on to the API gateway, which acts as an entry point for Alice to forward a request to the appropriate microservices. In this kind of framework, each feature has its own working microservice handling their own data. These microservices also have their own load balancers and execution environments to function properly. This means that the most popular content, the video uploading, the search function, the content catalog all have their load balancers handling the data and their execution environments to perform their functionalities. So, the developers are divided into small agile teams such as content team, video uploading team, most trending team, search team, etc. Each team has its own functionalities, like the content team consists of millions of TV shows that the application provides. The video uploading team has the responsibility to upload all the content into the application. The most trending team houses the most trending shows according to the geographical location of users, and so on. These small team of developers relate each and every piece of content with the metadata that describes the searched content. Then, Metadata is fed into another microservice, that is the search function, which ensures Alice search results are captured in the content catalog. The third microservice, that is the most trending microservice, captures the trending content among all the 𝐸 users according to their geographical locations. The content from this microservice is what Alice sees when she first logs into 𝐸. So, these individually deployable microservices are put into specific containers to join the application. So what exactly are containers? Containers are used to deliver the code to the sector where deployment is required. This means that they're plug and play. So if a microservice isn't working properly for the application, then the developers can take it out and replace it with a new one. But before they join the application to work together, they still have to find each other to fulfill Alice's request, which is basically how will they communicate with each other. Well, microservices use service discovery, which acts as a guide to find the road of communication between each of them. Microservices then communicate with each other via stateless server, either by HTTP or message pass. After microservices communicate within themselves, they have to deploy the static content to a cloud-based storage service that can deliver it directly to the clients via content delivery networks. So Sakshi has a question now. What are exactly APIs doing that we've learned in the architecture? For a microservice architecture to function, the infrastructure's components must be able to interact with each other. So, each individual microservice must be able to communicate with every other microservice in the architecture, as well as with the applications and the websites they power and the databases from which they draw real-time information essential for their functioning. So, when Alice searches for her TV show, the search microservice communicates with the content catalog service in API about what is exactly Alice searching for, and then these microservices compare the typed words with the metadata they already have stored in their database. Then, the most trending microservice captures the most popular data among all the users of 𝐸 and stores it in the database. Once the team of developers captured the most typed words by Alice, the analytics team update the code in recommendations microservice and compare Alice's most viewed content and the preferences to the popular content among other users in the same geographical region. This means that the next time Alice logs on to the application, she not only sees the most popular content but also finds a personalized playlist which contains the shows she has previously viewed. This is similar to how Netflix and Amazon work, isn't it? So in this way, Alice's request is fulfilled by the development team in a quick manner, as they did not have to build the complete application again and just had to update the code to deploy this new functionality. Now, coming to the practical implementation of microservices, let's look into how you can create and run Spring Boot projects on Eclipse for microservices. For this demo, I will be using Java of version 1.8 and Spring Tool Suite, which is a Spring Starter plugin. So you can download the Spring Starter plugin from Eclipse Marketplace. So this is an example project which demonstrates the use of microservices for a site offering various TV shows. This project backend is powered by 3 microservices: the user service, TV show service, and the user booking service. Let me show you the project structure of each microservices one by one. So let's start with the user service. Let me just open all the files. Okay, so the user service has an auto-created Java file which imports various classes and annotations. We import Spring Boot application so that it can trigger the configurations for enable auto configuration and others. Okay, now Harsha has a question on what does it exactly mean by exclude data source auto configuration. Well, this means that we want to disable data source auto configuration, Mongo auto configuration, and others for our application. Now, I've created another package for the controller file, and in this file, I'm going to import all the data from the JSON file in the resources folder. Let me just open it. Okay, so I've started the file by importing REST controller annotation so that we no longer have to add response body annotation to all the request mapping methods. After that, I've created a map object users which maps the keys to the values. So our key value will be of string type and the values would be of user type. So basically, I've created an object of hash map which is a subclass of map. So if you observe the JSON file, you can see that ID, name, email are mapped onto various values such as John, Jane, Ashok, etc. These fields are then defined in the user.java file under this package. Coming back to the controller file, the post construct method is used so that bean is fully initialized and you can use the dependencies. Moving forward, we have used parameterized type reference for typecasting. Basically, the purpose of this class is to enable capturing and passing a generic type. To capture the generic type and retain it at runtime, you need to create a subclass. The resulting type reference instance can be used to obtain a type instance that carries the captured parameterized type information at runtime. After that, to read the JSON file from the resources folder under the controller package, I have first loaded the class using class loader and then read the user.json file from the resources folder. Then a new object is created of file type and I've put the name as file. After that, all the bytes are read from this object and stored in a new object named content. So basically, what are we doing at the end is that we're retrieving the types from the content and storing in the object users. Now, to handle HTTP requests, I'm going to create a method inside the user controller class which can be called when an HTTP request is made. So when I just mentioned the port number on the local host, a message should return user service. When I pass the request /users on the port number 8084, the list of users should be returned from the requested method in the controller file. Now let's suppose I want the information of any one user. Then I will pass the request /users with the parameters as username to the port number 8084. Okay, so there's a question from Soumya that how do we set the port numbers for various services? To set the port numbers, you just have to go to the application properties in the resources folder and type spring.application.name is equal to your service name and server.port is equal to your port number. For the user service, I have put the name as user-service and port number as 8084. Similarly, I've done for TV shows where I've chosen the port number as 8082 and for user bookings, I've chosen the port number as 8083. After this, I've also created some files to handle the errors and the exceptions. Similar to the user service, the TV shows and the user booking service also have similar project structure but have different functionality. The booking service consists of all the information about bookings of users and this service works on port number 8083. Coming to the TV show service, this houses all the TV shows offered by the site and this application runs on port number 8082. So now that you know the project structure of all the three services, let's launch these applications as Spring Boot app. So for that, right-click on the project, go to Run As and choose Spring Boot app. At the end of the console, you can see that the user application has started. Similarly, launch the other two applications. So right-click on this project, go to Run As and choose Spring Boot app. Okay, so the TV show service is also started. Again, right-click on this project, go to Run As and choose Spring Boot app. So the user booking application has also started. Now that our three applications have started, let's go to the browser and check if they're running or not. So open the browser and type localhost 8084. You can see that a message has returned user service indicating that our user service is working. Now, to get the details of all the users, pass the request /users to this port number. So let's type /users. So you can see on the screen that the list of users has been returned. Now let's suppose I want the details of only one user, let's say John Smith. So pass the name John Smith as a parameter to this request. So John_Smith. This gives us the detail of only one user, that is John Smith. Now, if I want to get a list of bookings done by various users, type localhost:8083/bookings. So here you can see that Jane has done only one booking, John has gone for 2 bookings, and Ashok has gone for 4 bookings. And suppose if you want to see the bookings of Ashok, type Ashok_Kumar. So you can see that Ashok has gone for 4 shows: Modern Family, House, Sherlock and Vikings. To see how the last service runs, that is the TV shows, let's type localhost :8082 /TV shows. This gives us the list of TV shows that the site offers. You can see that each TV show is given an ID and has parameters such as title, rating and genre. So now, if you want to know who has booked a TV show, pass the ID of TV show and user bookings as a parameter to this port. So type localhost :8082 /TV shows / let's say we want to know for this particular TV show. Copy the ID and paste it here and pass the parameter user bookings. You can see that Jane has opted for this particular TV show. So well, that's how you can implement microservices using Eclipse and Spring Startup plugins. So thank you guys for joining in today's session. I hope that you've learned something useful with this session on microservices. So thank you guys for joining in today's session. Have a good day.